Hi, welcome to our last lesson in Chapter 3, our chapter on exponential and logarithmic functions. Today we're going to talk a little bit about how to use your calculator to assist you in coming up with an appropriate exponential or logarithmic model that will simulate a real life situation. If you don't have your graphing calculator out, you're definitely going to want to have it. You need to practice this as we go through. See, a lot of times just by looking at data in a scatter plot where one variable numeric is plotted against another, we can decide what kind of mathematical function would be the best or give us the best picture of a situation. That might be linear, it might be quadratic, could be exponential, hint, hint. So our calculator can help us do this. Now I'm going to say I want to have you plot this data by hand. This shows, it says, the populations of various cities. So these are cities around the United States, and the average walking speed of the people who live there. And one might imagine that the bigger cities, the faster people go, because it seems like city life is always in a hurry. And you can see that in general, that's what's happening here. I'm going to ask you to plot this by hand. When the population is about 5.5 thousand. So you guys, that's a 20th of the way through here. The walking speed is about 0.6 of a mile per second, which is like maybe right in there. When the population hits 14, so that's a bit more than 10% of the way through here, maybe around in here, the walking speed is up to 1 mile per hour. Feet per second, sorry, feet per second. When population gets to 71, so we're closer up here, about 3/4 of the way through, we're at 1.6 feet per second. When the population gets to 138,000, so that's right around in here, we're around 1.9. And if you think about this, folks, it doesn't matter how many people you live by. There's going to be some upper limit to this, and you can see it's kind of starting to do that thing. When a city has 342,000 people, so now we're about halfway through here, the walking speed is at about 2.2, so maybe right up in there. And that totally is an estimate. You can see from that that is a curved shape graph here. A linear situation is not good here. What I'd like to have us do is put that into our calculator, put the data into our calculator, and we'll take a look at how it displays that data and if the picture that it prints is similar to the one that we got by hand. To enter data into your calculator, it's the stat key and then edit. I always think enter means edit, right? The E. And what we're going to do is put populations in the first list, 5.5, so you just type the numbers in, 14, 71, 138, and 342. Those were the populations of the four cities that were in there. 5 cities, and here come their walking speeds in feet per second. 0.6 for the first one. You want to make sure that you have these guys in the same row since they're data pieces that go with each other. The next is 1, 1.6, 1.9, and 2.2. All right. To see what the calculator says about this situation, what its graph would look like, I will say this slowly and we're going to write it down on the next screen. But to turn on a scatter plot, it's the second key and y equals. Second and y equals. You can see that you have the capability of having 4 stat plots. We just are going to have 1. So on the first one, I'm going to go ahead and hit enter to get into that plot setting. I want to turn it on, so with the cursor blinking on, hit enter there. The type of graph that we're looking for is a scatter plot, and that's the first one. You may need to adjust that. I don't. Mine is set for scatter plot. The X list, so what we're trying to say here, or you can look at our graph, we think population is the determining factor. So our X list is list 1. Our Y list, that is the walking speed, we think depends on population. So the dependent variable is the Y variable, and that's walking speed in this one. You can choose any mark that you'd like here. You can have a plus sign show up or a dot. I always stick with what they give me. And one of the things that I will ask you to do, we're ready to look at this plot, but we want to make sure that there's no equation in our y equals right now. So I'm going to ask you to just check there. Oh yeah, I have a bunch that need to be cleared out. I don't want anything in there to distract from my scatter plot. I have a graph window already set up on my page. I have x's going from a minimum of 0 to a maximum of 400. And the scale, well, I have mine going up by 100, but you can make that whatever you want. You should not leave it at 1 though. You want to have something that breaks it up a little bit better. Otherwise your calculator has trouble pixelating it. The y minimum that I have is also 0, and that's one thing that I like. I want to see a true picture of my data, so I like to start at 0 and 0. I'm going up to 3 feet per second as my maximum speed with a scale of 1, and that looks okay. I do not know what xres is, and I do not need to know. In order to see this graph, I just need to hit graph now. And here I go. Yeah, there it is. And it does look similar to what we had plotted by hand. Let's go on, please. And I do want you to write down some of those calculator tips to put data into a list. It's the stat key and edit, which is the first option. To set up a scatter plot, it's second, y equals, and then get into the plot and adjust the settings that you want it the way that you want them to go. Second and y equals will get you there. Plot settings to get what you want. To view the scatter plot, you want to do at least many of you, you want to set up a window. A good choice, I didn't use this one a moment ago, but if you choose zoom function 9, that's a zoom stat window, it adjusts to your data set. Okay, it adjusts based on what you have in your lists. So that's a good one to choose if you're not sure about a window. You do want to make sure though that you don't have anything in your y equals. Now, the next two things we have not done yet. We want to see, the goal of this lesson is to get an equation, a model that fits the data. And I'm going to ask you to take a look with me right here. I'm going to press my stat key, and you will see you have 3 menus in the stat key, and we want the calc one. Under the calc menu, folks, there are all kinds of possible models for data. You could ask for a linear model, a quadratic model, a cubic model, a quartic model it's called. I would ask you to think about this. You saw our picture. I would guess that maybe it could be quadratic. The only reason I don't like that one is that I know quadratics go up and then down, and it didn't look like this was going down. Okay, it looked like it was growing, and it probably levels off, but I don't think quadratic is what we want. There is another model, another choice for linear regression, and I know it's not linear. Here's the natural log regression, which may be one that we want to look at. Here's an exponential. And for me, I think this is the one, these two are the two that I would look at first. So I'm going to ask it to do the natural log model. And I'm going to go ahead and hit enter on that. The X list, again, these are the default values. Unless you need to change for some reason, you could leave it there. The frequency list, as far as I know, you do not have to do anything with. Unless you want it to store the regression equation, which, and I've not used that feature, so I'm not quite sure how that works. I wonder if it gives you choices. Maybe it does. I'm going to have it store the regression equation in, I hit the var keys, yvar. I'm going to have it store it in yvar's function 1. And I think that, yeah, that'll let me put it into my y1. And then calculate. All right, you can see we have here a natural log equation. It's a, so there's an initial spot, plus b raised to the ln x right? And I want to see what that looks like. So it should have put that into my y equals. Yep, it did. There it is right there. I'm going to go ahead and hit graph again. Same window is okay. Okay, that's not bad. It hits every point. I can see it doesn't hit this one as closely as it does some of the others, but that's pretty good. As long as I can do this, I'm gonna check the other one. I want to see if the exponential model might be better. So I'm going to stat, calc, and this time I want to choose expreg. And same deal, I'll ask it to store the regression equation, only this time I'm going to ask it to put it into y2. So that was vars, y vars, so over function, and I'm going to ask it to put it in y2 because I may want to combine these. Okay, go ahead and calculate. And it did put it into my y2. This says an exponential model would be start at around 0.935 and then have a growth rate of about 1 per time period. Let's see what this one looks like. Whoops, there's our first. Here comes our second. Yeah, I'm thinking that the natural log one is a little bit better fit. That doesn't even come close to modeling our data. So that natural log one was our best bet. Okay, there is a way. I'm going to go ahead and clear that off of there, and I'm going to turn on a function that will give me a measure of how good of a fit we have. So I'm looking in my second and catalog. And what I want to look for is diagnostics on. So these are in alphabetical orders. Okay, diagnostics on is what I want. So find that it was second and catalog, and then I scrolled through them until I found diagnostics on. Go ahead and hit enter here. See, it says done. From now on, what this is going to do is show me a value for R, which is Pearson's correlation coefficient. You've probably not learned about that before. If you have, I'm very happy, but if you haven't, what that does is tell you how good of a fit an equation is to a data set, and the value of R can range from -1 to +1. -1 would mean that there is a negative trend to your data. +1 means there's a positive trend, and the closer you get to either extreme, the better fit you are. So I want to go ahead and do this again. So the value of R squared here, R 0.999, Pearson's correlation coefficient, R squared. Some of the other regression models use R squared as opposed to R. So I just want you to keep this in your head, 0.999 essentially, if you round it up, 0.999. Let's check. I'm going to go back and look at the exponential model. Even though I know that wasn't a very good fit, I just want to see what the value of R is. So I'm going to go to expreg, and here goes the business again. The data is in the list, and I don't want to store this equation because I know it's not a great one. Oh, look at that. R squared 0.61, much, much less strong, right? For our model, the natural log equation was way better. Let's see if we can't. To get a regression equation, it was stat, and then over to calc, and then choose which one fits your data, or which one you think might fit your data. Choose a model. To paste the equation into y equals, in this edition of the TI-84, I was able to do that when I set up the linear regression. If you have an older model calculator, you will have to follow some different steps. To paste the equation into your y equals, you would have to hit the vars key. Actually, you have to be in y equals. So you get into y equals. You clear out what's there if you want to. And I am going to clear out what's there. So y equals and clear. And then it is vars. And you want a statistical graph, at least this is how I think of it. I want a statistical model, so I choose number 5. What I'm interested in is the equation, so I'm going to over twice. So over here, over to EQ, and I want to choose reg EQ. That'll put the regression equation into my y equals. This only works if you have regression data on your calculator screen. I'm going to get out of here, second in mode, and show you, oh, I lied. So that'll put the last regression that you called up into your y equals. To determine which model fits best, you should check R or R squared. The closer to 1, the better the fit. Actually, it's the closer to positive or negative 1, the better the fit. Many calculators, so since as we said, most things that happen in the real world can't continue to grow forever, and exponential and logarithmic functions do that. A function that has a horizontal asymptote that limits growth is helpful. Many calculators include that. It's called the logistic function. If you do not have the logistic function on your calculator, it's okay. Choose that natural log, which is probably very close to as good of a choice. Okay, yeah, as we said, just be aware your exponential or logarithmic function, it might not be as accurate beyond or outside of the range of your data. Interpolation, that is choosing an x that's within your data range, choosing x in your data range, makes for pretty good predictions. However, extrapolation, which is choosing an x value outside of your data range. So if you're trying to predict years into the future, choosing an x outside your data range, you may not be as safe, folks. As we said, things change, and unless the model stays exactly the same, any prediction that you make, if that's the idea that you want to make predictions about what could happen, getting too far outside of your range is dangerous. You can predict, but it may not come out that way. All right, I believe that brings us to the end of this lesson. I'm going to go ahead and say try the U-try right now, and in class we'll talk about this more tomorrow.